Today's topic of discussion is the continuation of recurrent neural networks. Okay, recurrent neural networks is a type of network that has been designed to work with sequence of data, mainly text data or series data. So essentially, recurrent neural network has been developed to perform operations like um, this machine translation and text operations on text, image captioning. So we know that there are different types of RNNs, and RNN architecture is this. We have input layer, output layer, and hidden layer. Hidden layer shades the weights, and now we'll look at the working of RNN. This is output y1, y2, yt. Okay. H1, H2, HT. These are hidden units. X1, X2, XT. These are input units. Here, this X1 and H1 is connected. There is a connection, and there is a value U, for this connection. Here also you have U. Here you have U. So what are these U's? These are the connection bits between inputs and hidden units. Then hidden units to output units. we have V, V, and V. These are the connection weights between hidden units and output units. All right, and then these are the weights between the uh, hidden units which are shared among all these units. This thing can be written as HT, hidden unit at T. This is tan H. Tan H is an activation function, and U of X T plus U of X T is this U, and this is X, means input into this weight, this connection weight, plus W H T minus 1. What is this? W, this is W, and H. For H of T, when you are calculating, you are taking W into H of T minus 1, H sub T minus 1, which is this one. And when you are doing at this layer, uh, uh, this unit, this will be H of T minus 1 is equals to tan H U X T minus 1 and W H sub T minus 2, this one. It is this way. And Y of Y sub T equal to softmax. This is the activation function at the output layer. VHT. This is V. Okay, because we are at here Y sub T. This is V and this is HT. All right, and for HT as well, this one XT and this U, and this is H sub T minus 1. These are the activation functions and operations that are performed, and this X is a feature vector. Okay, next we will look at the detailed uh, application of activation functions in RNN. This X1, X1, and here you are calculating H1, which is equal to tan H U X1 plus W H input, some initialized value will be there, no? That one, that WH input. And then this is V. And what are you getting here? Y hat. Y not hat is equal to softmax. Here we use softmax at the output layer. Softmax of V into this H1. Okay. And then there is an input H in, and there is a W. Then next what happens? H2. H2 same tan H, UX2 plus WH1. And this gets X2 as input, and Y1 hat is equal to softmax of V into H2. Here there is weight W. Here also you see there is a weight. Here also there is a weight. And H3 is equals to same tan H UXT, or here let us give 3. UX3 plus WH2. Okay. And here at the output layer, you have Y2 hat is equal to softmax of V into H3. Okay. This is how values are calculated in recurrent neural network. Any doubts in this? And what happens is this X input is a feature vector. So there can be n units in X node. 1, 2, 3. This is X1. And corresponding number of nodes in H1 will be same as X1. So this is 1, 2, 3, dot, dot, dot. Likewise, similar number of values in Y. And these are connected. And this one is also connected. And then this one is also connected. Likewise, all are connected. Same thing happens here. Okay. Um, Consider that these are n nodes, n units, and these are d units, and these are k units. Then what will be x equal to? X is equal to x naught comma x1 so on up to x sub t minus 1. And what is the dimensions of this? N by t. There are n units and total, you know, t is n units, n by t values. And then u is what? It is an input to hidden layer weight matrix. It is a weight matrix from input to hidden layer. And it belongs to the dimension, its dimensions are d by n. There are d units and connected to n units in the input. And what is v? V is equals to weight matrix from hidden units to output unit. And so weight matrix from hidden to output. And its dimensions are k by d. It's k by d. Okay. And W. What is W? W is weight matrix from hidden layer, hidden unit to hidden unit. Hidden to hidden. And its size will be d by d. Size of the matrix. All right. This is all about the recurrent neural network architecture and the weights and the sizes of each weight matrix. Next, let us look at forward propagation. Forward propagation. As ANN, artificial neural network, and convolutional neural network operates, in two phases. In the first phase, it is forward pass, which is nothing but the forward propagation, and the second phase is the second pass, which is back propagation. Same thing happens here as well. And the forward propagation, how it happens is that there is this direction from input to output. This is forward propagation, as well as there is this direction from uh, input to all the hidden layers, through all the hidden layers. So this is forward propagation. What happens in forward propagation? Essentially, it is all about uh, working with the input and the weights to get the predicted value. If ht is equals to tan h of uxt plus wht minus 1 and yt is equal to softmax of vht, and what will be the loss? In forward propagation, loss is generated and computed. Um, Actually, the generated value or the predicted value is this y hat, and loss is computed from this actual log predicted. This is for single sample, and when you take this for all the samples j equal to 0 to t, loss of t. This one is this one normal, just this t, y sub t. This is actual value, and this y sub t uh, hat. This is the predicted value. For every predicted value, if there are 100 samples, then you get 100 predicted values, one for each. First one, for first record, there is an actual value, which is the correct value, which is denoted by y sub t, and there is a predicted value, which is denoted by y sub t hat. You just put them up in this equation, minus y sub t log of y sub t hat. When you put this for 1, 2, 3, same, okay, up to 100, and then you, if when you take the summation, if you take, if t is 100, then here t will be 99. You are starting with the 0, and 0 to 99 you compute this. This is lt for each one, and then this lt you do for every sample. You get the this loss for the data set, loss for one particular data set, and that you need to improve, you need to refine it so that you reduce the loss, and that is done. Excuse me.
بس بدنا نمشي يا ياسر. ما بتروح يعني؟ طيب تروح المستشفى كيف؟ بديت قبل شوي رحت له قال لي جاهز. إذا بابا خلد أنا قلت له خليه على أساس إنه بروح فيه الصباح النادي 8. بس بس في نمت متأخر. إنه أنا أخذته منه قلت له خليه على أساس بروح الصباح 8 النادي، فهمت؟ بس أنا نمت متأخر فما قمت 8. الحين أنا بروح باخذ الفزيت وبروح النادي عشان هو بيجي ساعة 1:30 النادي أكيد. بيجي بيمر بالبايك تلاقيه كمان دق في الواتس بعد يقول شو بعد شوية. والله دوبنا فطرنا الحمد لله. صالح ايش صار عليه؟ أحس ما زبطه؟ ما أدري تحسن في المطبخ.
Sorry, students, I had a call. Okay, that was forward propagation. it computes the loss. In recurrent neural network, backpropagation algorithm is known as backpropagation through time, BPTT. Okay, backpropagation through time. Here it is. It is a gradient-based technique for training certain types of recurrent neural network. However, the BPTT has difficulties to get out local optima because with RNN, the feedback tends to create chaotic responses. Okay, before that, let me tell you what is this back propagation through time. In this, we have weights. What are the weights? W, U, V. W are the weights between hidden and hidden. U are the weights between input and hidden. And V are the weights between hidden and output. Now what happens is these three kinds of weights are trainable. These are trainable parameters and can be updated um, through BPTT, back propagation through time. Okay, let us look at their equations. So you just try to find the derivative of loss with respect to V. Okay, and likewise you do for W and you do for U as well. So here W is equal to W minus this alpha is a learning rate for W is equals to W minus alpha. This is the derivative of loss with respect to derivative of W, this W weights. Then V is equal to V minus derivative of loss with respect to derivative of V. And for U also same. U minus, okay. So by using these three formulas, W, V and U are updated. And again, the process of this back propagation through time updates these weights, and again forward propagation takes place. Loss is computed. Further BPTT run unless and until the model converges. This process continues. Okay, so this is all about RNNs and their architectures, then forward propagation, backward propagation through time, the training and their weights and uh, their this equations. Okay, these variables and their sizes. This is all about that. So next topic is LSTM that we will see tomorrow. Okay, students, any doubts? Okay, then bye.